Hello students, welcome to this video series on software engineering. Now we have discussed class-based modeling and the scenario-based modeling. In this video, we are going to learn about flow orientation modeling, and that actually tells you about the flow of the data from the input states to the output states, and how the thing is going to process that we was not part of the class based modeling or the scenario based modeling. And then we will also see something called behavioral modeling in form of state diagrams and sequence diagrams. So it will complete the requirement engineering part. So the data flow diagram is a part of a flow based modeling, takes an input and process it in output view of a system. The data objects flow into a software and are transformed by the processing elements, and resultant data objects flow out of the software. Every system that we create, a software system or a mechanical system that we actually see around, has the same type of structure, that it takes in the input, it processes the input, and it sends out the output, right? Anything. If you take a printer, the printer takes data from the system, it processes the system, it creates prints, and it displays the output as a printed form. Data objects are represented by a labeled arrow, and transformations are represented by circles, also called as bubbles. So we will see how a DFD actually looks like in the next slide. But as of now, understand there are two major things, that we have arrows and we have bubbles. Along with this, we have rectangular boxes which represent the classes or the entities that actually takes the data and send out the data. The DFD is represented in a very hierarchical format. So it says you keep on adding the information as you go by the hierarchy. So if I say that the first level of hierarchy is called as context form, the zero level DFD, level 0 DFD, and it is the most abstracted form, that it doesn't tell you about what is the process. It always tells you about what are the inputs and what are the outputs. The next level will be expanding of the process, keeping intact the input and the outputs. Okay, so to understand this, let's see one simple diagram from the SE-form scenario. It says this diagram actually tells you about the SE-form process. It says that the SE-form process will take an input from the control panel as a user commands and data, and it will also take input from the sensor class for the sensor status data. So these two data will be given to the SE-form process. The process somehow will actually give you three different type of output. You don't know how the process will work, but as of now you understand, a user is telling you that I will give certain data from the control panel, and I have some sensors installed in the house. The sensors are giving data to this SE-form process. Now the process will actually display some information. It can raise an alarm, and it can also call the telephone line, telling you in case of a fire or a smoke. So these are the three outputs, and these are the three inputs. Okay, so we will see, we have actually seen this. That means you are having you have this three as an input here. Sorry, you have this 3 as an input here, right? No, 2 as an input here, 2 values as an input, and the 3 value as an output. Okay, and this is the process. Okay, so the process itself is in a bubble form, the inputs are in rectangular form, and this arrows tells you about the input data or the output data, and you write whatever things has been done by the input and output. So this is the level 0 or the context level diagram for a DFD, right? Now based on this, in the next level, once you understand what are the inputs and what are output and what is the process that you're going to work on, what you can do, you can expand this process. You can expand this process, keep it intact, the inputs and outputs. So in the next diagram, we will see that we have expanded the safe home process. Okay, so this is the complete safe home process. This was the SE-form process. So I have two inputs, control panel and sensors. I have three output, control panel display, alarm and the telephone line. I have those as a display, right? So I have seen this. Now so these are, so in the level 1 what it does, it will actually intact, it will expand the save form process. Now you can are in a better position to understand that control panel is giving the user command and data to a process which is known as interact with the user, right? On the other hand, sensors are giving its data or sensor status to a process known as multi-pointer sensors. So in the previous diagram, you actually see that those two inputs are coming to just the waveform process. Now in the second diagram, it is more clear that these two might be coming to the same waveform process, but they are not going into the same process at that time. They are going to a different set of processes, and those two different processes are now going to work with multiple other processes. And there is something called database also. This is a configuration database that actually stores the data here, right? Now it's again that the display messages is coming from a process which is a display message status, and the monitor status actually giving you the two different outputs. So these two outputs are coming from a different process, and this is coming from a different process. So this is the level 1 DFD. Now if you want to expand, you can expand any one of the internal process in the level 2 of the DFD. Suppose we expand this monitor status in our next level 2. So level 2 actually has this particular set of data. The level 2 mentions a monitor status process, right? So the monitor status process now actually tells you about that the sensor status now coming and reading into the sensors. Now it will again go and interact with another type of process, and finally these two data that you see that comes out of the monitor status, okay, as actually you are seeing this one process now, and it says that this process is giving you two outputs, but what is there internally this process has two different processes, like format for display and generate alarm signals. So these two are different process, and these two are different process. So it gives you an alarm type and telephone lines coming out from this particular set of processes. So in each level of DFD, from level context level to 1 or 2, you are going to expand each and every process so that you understand how the data is being transformed from input to an output, and which process is going to transform that, which process is going to do that particular type of transformation. This is the main motive of the DFD. We will use a DFD, or we can understand better the DFD when we will see the sizing, and we will talk about function point in next videos. But as of now, understand that DFD is not a part of a UML. As of now, they had been removed that, but it is a very powerful tool to understand how data flows from an input to the output. Now coming to the next state representations, that is this comes under the preview of a behavioral modeling. So in behavioral modeling, the thing tells you about the behavior of system, how system behaves, right, when you provide certain inputs. In the context of the behavioral modeling, the two different characterization of the states must be the state of each class as the state performs its functions. So if I have, suppose, a switch called S1, a state called S1, and I have state called S2. S1 is labeled as on and S2 is labeled as off, right? So these are the two states of a system. A switch, you can see the switch around you also. So if I have a switch and it is in the on state, if I press it again in the on state, the state won't change, okay, until unless I do a reverse operation and I go to, if I off the switch, the system will go to the off state. Now if I'm in the off state and I'm trying to off it, it will again be on the same state, right? Until unless I turn this switch into on, the system will come back to the on stage. Okay, so this thing is the first part. That means the state of each class as a system performance function. That the function of this class is to on and off. So whenever I will do a switching between on and off, the system will change. Until unless you are changing the system won't change. Second thing is the state of the state system as observed from the outside as the system performs function. So I want to see uh, from an outsider actually views the system as a as a function of time, right? At what time what thing happened, at what particular instance of the time which thing is occurring, right? This is called as a sequence diagram. The first indicates how an individual class changes state based on the external events, like as off and on are the events that I do on S1 and S2. And the second is the behavior of software with function of time, that what time how much time it takes from S1 to S2 or S2 to S1, and at what time the thing is being switched and how frequently it should be switched. Okay, so we will see this two type of representations in our next video in the following slides. So one component of the behavioral model is the UML state diagrams that represents the active states of each class and the events that triggers that causes changes between these activities. So this is the example of a state diagram in which I have certain states, like I have a state called reading. I have a state I can see a state called reading. There's a state called comparing. There's a state called locked. There's a state called selecting. Okay. Now these now this the next part I can see the definitions also of these things. The arrow represents the transition from one active state to of an object to another. So if I say this is an arrow, it's coming from a locked state to the reading state. It says that when this locked state will going to transform into the reading state. Then I have a reading state going into the comparing state. I have a comparing state going into the selecting state. So these arrows will actually tells you the transition of one active state to another active state. Okay. Secondly, these labels that are written on top of the arrows actually are represent the events that triggers the transition. So if I say this is a black dot, this is the start of any event. So it say whenever you do a key hit, the system will start reading it, right? Once you enter a password, the system goes into comparing state, and when the selecting state is successful, it will come back to the reading state. Okay. Likewise, these labels can also be a guard, like an event, right? A label can be an event, or label can be a guard. A guard actually, a guard and an action, the guard depends upon the passive state of the object. So a state can have a active state, and a state can also have a passive state. The passive state actually means at the time it is processing, not switching it. So this guard actually tells like this one. The timer is less than equal to lock time. So there should be some lock time. Suppose the lock time is 4 hours. So it will have a timer which will actually monitor whether this lock time that we have exceeded the lock time or not. Till the time the timer is less than the lock time, it will go again in the same state. If the timer exceeds the lock time, the system go and read it the next value, right? So this guard actually helps the state itself to maintain the authenticity of the state and the integrity of the state. I have to use the guard condition. Okay, so a state diagram actually has the event, it actually has the guard, it actually knows the states, and it also have the arrows. So basically three things. And there is something called actions now. An action occurs concurrently with the state transition. As a consequence of the it generally involves one or more operations responsibility of the object. So can you identify the actions connected to the password entered event? So if you know, just comment it out in the box. So I may know that people are understanding it. Okay. The next thing is called the sequence diagram. It indicates how the event cause transition from an object to object as a function of time. When we go from object to object, not class to class, object to object with a function of time, we should know which object is called at what instance of time. It represents the key classes and the events that cause behavior to flow from class to class. Unlike a state diagram that represents behavior without noting the class involved, a sequence diagram represents a behavior by describing how class move from state to state. In a state diagram, I don't have the information about the object or the class. I generally have the information about the state. But a sequence diagram actually depicts the state as well as the classes involved in that state. Suppose this is a sequence diagram. It says that I have a class called homeowner, right? So a homeowner, a control panel, a system, or a sensor, right? So this is the states. These are the states, right? And these boxes that we represent here are the time. It is measured vertically downward, and a narrow vertical rectangle represents the time spent in processing an activity. So when the system is ready, and the system takes some time in reading it, and then when it reads it, it will send a password, right? It's ready, it will give you a password. When the password has been done, the system goes into comparing state, and at that time it will send a lookup information to the system. The system will take certain amount of time in looking up the password, verifying it, and sending the result back. So when the result comes back, the system again processes certain amount of time, and it sends whether the password is correct or not. If the password is correct, the request activation has been done, and after this particular amount of time, the system comes back after successful implementation, right? And then activation is successful. Otherwise, what will happen, the system is, if it is not correct, the system will switch to the another state, which is called locked state, and it will have to do something. These states are part of the control panel, right? And system and sensors and the homeowners don't have any state as of now. But if your system also has certain states, sensors also has certain states, then you must have depicted them with the state information also, like this. Okay, the state may be shown along the vertical timeline. So this line sometimes is called the lifeline of the class. So it's measured vertically. So this particular state diagram and the sequence diagrams tell you two things. The state diagram tells us about the states of the states of the entities in which it lies, how the state changes based on the external events or the triggers, and the sequence diagram tells us about how the classes move from one class to another class with respect to the time, and which class is called before another class and which will call after it, and at what time how much time it will take to process a particular class. Okay, so this was all about the state diagrams and the sequence diagram. With this, we end the particular topic of requirement engineering in totality, which should be covered in this course. And in the next, we are going to learn about matrices and the software sizing approach, which falls under the preview of software planning. Thank you very much. And it's also requested that there is some questions that are being given part of the videos sometimes, like in this I have shown you a diagram, a state diagram, right? And I ask you to answer a question: can you identify the action connected with the password entered event? It is expected out of the students who are viewing this, so they should try to pause, look at the diagram, give the answer in the comment box, so that I can identify yes they are correct or not. If you are correct, I may also give you an answer back. If you have any queries, just comment it out. I will be happy to answer those queries as well in the comment box. So thank you very much.